Yes, dear, I'm waiting for you. What observations are made? Were 3. Hello, can you hear me? I know you can. I had forgotten that I'm recording, so I hope that you've done that already. We've already talked about those in our first diagram. The proton is found in the nucleus and is positively charged. The neutron is found in the nucleus as well and has no charge, 0 charge in other words. And the electron is found outside of the nucleus, in other words, found on the shells or the orbits, and its charge is a negative. And then in the Rutherford's experiment, we found out that the nucleus is massive. That's where you find much of the mass of the atom. And from this table here, we're also seeing that the proton and the neutron are all having a mass of 1, 1, 1, 1. So when you combine the two, the nucleus will be having a mass of 2. You may not mind about the units now, whether they're kilograms, we don't know that at this moment. So that's not our concern right now. What we need to know is that the proton and the nucleon and the neutron all forming up the nucleon, it is a very massive part of the atom. Later on in our year 13, in case we continue with physics, we will be finding out more about the masses and their units. And then we also talked about this, the difference between atomic number and atomic mass. Atomic number of proton is the nucleus. Atomic mass, or what we call the mass number, or the nuclear number is number of protons and neutrons in the nucleus of the atom. So don't forget that as well. Then, how do we represent an atom? For example, lithium, how do we represent it in physics and in chemistry? So let's have this subheading here. Nuclear notation. Write that one from the margin. Nuclear notation to the subheading. To the subheading. And we have an example there. We have an example there. But before we do this example here, I want to ask any one of you to first of all remind me the answer to this. What is the atomic number of this carbon? And what is the atomic mass of this atom? Anyone, feel free. From what we've just discussed, we have this question here.
Atomic number is 6.
That is correct. Why?
Because protons are 6.
Okay, that is correct. And then atomic mass?
14.
14, very good. 14, very good, very good, very good. Okay, so we can represent that one using this letter here. I just want us to write this. You can write the whole of that, what you see on the screen, and then you have this note here. Note, my pen is not the best, so I'll keep on reminding you of this. In 10 minutes time, shall be closing this supply. I'll try to be fast. N is the number of neutrons. Number of neutrons. Yes, I done. When you're done, I just need to hear one yes, and then we continue. Just one yes, and we continue.
So what is that thing before number?
Proton is plus neutrons. Number of neutrons, the small n. Number of neutrons. So the next question, I'm going to give you only this symbol here. And then I ask you that what's the number of protons, what's the number of neutrons, what's the number of neutron, protons, electrons, and so on. So I hope that you are ready to answer that, my friend Mega. Shall we? We have like around 8 minutes. I hope you're done, Mega.
Yes, sir.
Okay. Let me first take you to this. We have that question there. Okay. Okay, let's have this question here. Just write the question and then give me the answers. And it is not your responsibility. It doesn't matter whether you know this, the name of those elements. The nitrogen, the cobalt, the silver, and the plutonium, I guess. I'm forgetting the other one, the Pu. It is not your responsibility to know those. Just know that this letter down, this number down, this number up means this one. That's all you need to know. Anyone who has got the answers, please let me know.
So we are getting the one for protons and neutrons combined.
Not really.
Okay.
The question is just asking that determine the number of protons and neutrons in the isotopes below. Just to that. So what is the number of protons? What is the number of electrons? Actually, let me add on this one here. Let me add on this. Electrons. Electrons. Add this there. A number of electrons, comma, Banang. I know Mega is saying Banang. Mega, not so. You're saying Banang. What is this? Number of, this pen needs me to press. I'm using a lot of energy. Number of electrons, comma, protons, neutrons are in the neutral isotopes below. So electrons in this, how many are they? Protons in this, protons in this, how many are they? And then neutrons, how many are they? So anyone who has got me the answer for the first question?
Uh,
Yes.
the protons are 7.
The protons are 7. That is correct. That is correct.
The neutrons 6.
Okay, that is correct. Then electrons.
Electron.
There.
I don't know.
They are 7. Remember, I said that number of protons and electrons are the same. If there are 7 protons, then there must be 7 electrons. That is in case it is a neutral atom. Otherwise, if it's not neutral, then the number is not equal. Okay, can you complete the others? Yes, what have you got? Electrons, protons, and then neutrons. My pen. Oops. Electrons, protons, neutrons. Then electrons, protons, and then neutrons.